Good afternoon, good morning. I don't even know when we are. Good morning. Oh, very energetic. Let me just point out that all of you walked into a room where on the screen was a console mode debugger, and you said, hey, this looks like the session for me. And you carried right on in. My name is Chris Jackson, and today we're going to be talking about Windows 8 security internals. And by internals, I mean very deep internals. What's going on to make the operating system behave like it does, and we're going to tie that back to the configuration choices that you make. But this is Windows internals. We're not talking about firewalls. We're not talking about antivirus. We're not talking about these higher order things. We're talking about the guts of the operating system and trying to explain a lot of the very complicated underpinnings that make Windows behave the way it does. Along the way, I hope to give you some tools with which you might be able to demonstrate this to other people, one possible side effect, because most people misunderstand that. For example, how many of you have, at some point in your careers, disabled UAC on some or all of your computers? And leave your hand up if it's still off. We're going to talk about why that's not probably the best going forward plan, and give you some examples and help you understand this feature set top to bottom, and then drill into how that applies to Windows 8 apps. Does that sound like what you thought this session was going to be? Fair assessment? The other comment I'll make, this is going to be a PowerPoint-free zone. There will be 0 PowerPoints. I will be presenting without a net, if you will. What I didn't know until recently is that you are required to give the PowerPoint team money if you don't use PowerPoints at any presentation anywhere. I don't know if you knew that or not. I don't have that much money, so I had to go out and get a sponsor. So we're going to start off our session with a word from our sponsor.
Years and years ago, in 2005, computers used to look like this. Back when I was 1 year old. Look at this thing. It weighs way more than me. With Windows 8, my surface looks this small. And it is so much more powerful. And it also features mandatory integrity control. That's one of UAC for all your non-hackers out there. It keeps me safe when people try to hack me. I had my credit card number stolen 5 times. I don't even have a credit card. Now I'm protected by application isolation. It keeps me safe when I run my Windows 8 apps. There's lots of bad hackers. Someone's trying to hack me. I'm a hacker. I'm a hacky player. Own it. What I'm talking about. Windows 8. It is made of pure awesome sauce. Yankee, awesome stuff. I want you to have my good player.
So now that we've had our word from our... Thank you. I think there are child labor laws out there that technically prevent me from doing that, but as you can see, I conveniently ignored them. What's interesting, though, is that I gave this presentation previously at an internal conference, and I actually got some feedback of, wow, there weren't any PowerPoints. I'm like, wow, really? Like, that's actually, like, you didn't get enough PowerPoints in the rest of the conference? So I wanted to respond to that feedback, because feedback matters. So let's see if we can respond to the feedback of, let's keep this as nerdy as possible while incorporating people's interest in having PowerPoints. So we'll go ahead and set a breakpoint on user 32, set window text W. This is how you normally start PowerPoint, right? EZU, we're going to modify memory at EAX, and we'll do an escape quote titled PowerPoint, escape quote, semicolon. We'll disable breakpoints, and then we'll go conditionally. Whoop. That didn't work out well. Try again. User 32, bang, set. Why, I kind of blew my groove there, didn't I? Set window text W. EZU, at EAX. This is much funnier the first time. PowerPoint, escape quote, semicolon, BD star, semicolon, GC. Go, and now we have our PowerPoint right there. And so we'll quickly go over what it is we're going to talk about to, again, super clarify the path we're going to take. We're going to talk about tokens in Windows and elevated tokens, which is something that comes about as a process of doing UAC. And I talk about this because Windows is the only commercial operating system in which you have the exact same identity with two different privilege sets. If I'm on Unix, I have my account and I have root. They're different identities. On Windows, we have two, and that's why we talk about it, because that's really hard. We're going to talk about integrity levels and explain some of the complexity there, most of which people aren't aware of. We'll talk about UIPI, your user interface privilege isolation. And we're going to then talk about how that all integrates together to form the baseline of security for Windows 8 apps. This applies to the desktop, and it applies to the immersive apps, or whatever it is we call them these days. I'm not in marketing, and I can't make sense of what they say either. We're then going to go into some of the things that are specific around Windows 8 apps, such as capabilities, which are also represented in the token, and we're going to talk about app container SIDs and explain all those new different components of an identity. So we're really going to go end to end on what gets fed into an access check and defines permissions. So if you're ready, buckle your seatbelts. Let's start off by talking about tokens in general. So I just need a new command window. We're going to use a command called whoami and dump all of the credentials in my token. I'm going to then launch a second command prompt, and I'm going to right-click and run this one as administrator. Whoami/all. From a demo purpose point of view, you may notice, conveniently, my elevated command window is red, and my non-elevated one is blue. What magic did I use to do that? There is no secret. There is no detection. All I've done is I've launched my command window from two different shortcuts. When I launch the blue one, I do window RCMD. When I launch the red one, I hit the start menu, I type command. The customizations are saved per shortcut. That's why they look different. Really helpful for demonstrating the two because you can really clearly see the difference between them. Now let's look at the contents. When I look at the difference between these two identities, you can see as I tab back and forth and the colors change, my SID never changes. It's still the same me. Right? One of them is what we call the filtered token, and the other is called the full token. This has been true since Vista. I understand this is probably review for a good percentage of you. Right? So I'm going to focus on also giving you demo tips, because for a good percentage of the rest of the world, they still haven't figured this out yet, because it's hard. The first thing we come across is that there's a difference in built-in administrators. It doesn't look like a regular group. It has what's called the deny-only flag. That means we can use your membership in the administrators group to deny you access to something, but we cannot use it to grant you access to something. A lot of people get confused about that. I'm a member of the administrators group. The ACL on program file says admins can write there. Why can't I write there? Because your admin entry has a deny-only flag on it, and writing is a permission. That's an allow operation, and that's the difference. As I continue to scroll through, you notice that my group memberships all stay the same. It's the same me all the way down. You also notice I belong to entirely too many groups. But then we get down to where things begin to diverge again. The first area is in this construct called the integrity level. My elevated token is running at high mandatory level. My non-elevated token is running at medium mandatory level. When we talk about integrity levels, we'll go into the details of what that means. The final difference is in the privileges that are held. A way to explain privileges to someone who's just kind of getting started into security is to think of it as explicit permission to do something that violates the central tenet of being a standard user, which requires us to understand what that central tenet is. The easiest way I found to explain it is, if I am not an administrator, I should be able to hork all of my own stuff if I want to. Hork is a highly technical term. That means mess something up. But I should not be able to hork the entire computer or any other users. If I am an administrator, I should be able to hork whoever I want to who's on that box. And that applies across the board. You can use that one simple rule to figure out what you can do and what you can't. Can I modify something in program files? It's shared. Therefore, it's going to impact someone else on the computer. Therefore, no. My documents, you've got your own. You can delete all of them if you want to. You can make new ones. It belongs to you. It doesn't affect anybody else. Therefore, you can. Privileges are explicit permission to do some operation that crosses that boundary. For example, shutting down the computer. Shutting down the computer has an obvious impact on other users of the computer, in that the computer is now off. But I've got permission to do that because it's really hard to have a standard user desktop where no one can turn off their computers. That's a little bit silly. Undocking it, same way. If we don't give you permission to do that, what are you going to do? You're going to yank it off anyway. So we give them permission. One of the changes we made in Windows Vista was we added a new privilege called the time zone privilege. That was the hugest pain point. How many of you have run non-admin XP desktops and then gotten on an airplane? Because you can't change your time zone. Now, what some people would do is they would give you the SE change time privilege, which lets you modify your time zone and the system time. Modifying the system time remains and ought to be an administrator operation. Why? A couple of reasons. Denial of service, for one. If you're doing Kerberos authentication, you've got to be within a certain tolerance of the time the server says, or you won't log in. More importantly, audit trails. If I want to do something bad, what do? I change the system time to a time when I was verifiably not anywhere near that computer, do the bad thing, change it back, and now they can't prove that I was there doing that bad thing because I can say, hey, here's my alibi. Go talk to that person. I wasn't here at 10 a.m. when it says that the operation happened. So that remains an admin operation. We now have the ability to change the time zone without going through and having it that way. So there's a handful of things that you can do. But as a full admin, there's all kinds of stuff that you can do. You've got SE Backup, which allows you to read anything you want to on the file system without an access check. SE Restore, which allows you to write anything you want to without an access check. SE Load Driver lets you load kernel mode drivers. Also kind of a security-sensitive thing. There's a huge difference, and we filter it down. The set of privileges we have in this filtered token very closely emulates what you would find in a standard user's token. So that's the foundation, the token work and the elevation prompts. That's the difference that we're getting between those two. And what we're really going for in terms of who should be using what token, I still today find it really hard for people to get to the point where even their developers are running as standard users because they have enough tasks to make that impractical since they require admin rights to do those tasks. But if we continue to let developers run as full administrator all the time, they bake in all kinds of accidental dependencies on being an admin. They didn't mean to. They said, hey, I need to write something somewhere. Where should I put it? Oh, here's a folder with my app's name on it. Seems like a good place. It's in program files. I don't see why that's a problem. And they go ahead and write there. By having it trigger early and having them able to run in what looks like a standard user desktop, but still do what they need to when the need arises, that allows you to start having your developers churn out software that works correctly. So that's our foundation. We've got a filtered token and a non-filtered token. Let's get into some of the slightly more complicated things beyond that, right? Let's talk about how the tokens come to be. Right? When I start up the computer, I've got win logon. going in and creating my elevated token, and then creating my filtered token. And then we go ahead and launch Explorer.exe using that filtered token. And the way that Windows works is whichever process creates a new process, you just inherit your token from the parent process. That's where it comes from. So we've launched Explorer using the filter token. Most people launch stuff from Explorer, and therefore it also inherits the filter token unless you go through an act of elevating. Other consequences. I'm always looking out for unintended consequences, because that's one of the big pain points we see is stuff that, hey, it sounds like a good idea, but this thing also happened, and that's not good. What's a consequence of this? Well, what's interesting is that when we store a list of your mapped network drives, where do we put those? We put them in your logon session. Each of these is a separate logon session, which means they each have their own independent private collection of mapped network drives. And if you've not run your script that maps your network drives in both contexts, you won't have all of the same mapped network drives because of that architecture. Now, you may be asking yourself, why did they do that knowing that was the impact? It's because that's where we historically stored them. You can go in on XP, use runas.exe, launch it as the exact same user as yourself, and get the exact same impact. The difference is, on XP, who would do that? Whereas on Windows 7, anyone who elevates would do that. But if we change the architecture, you would be flummoxed by the sheer number of applications that break as a result of that. Right? So now we've got a choice. We sort of magnify one impact from map drives, come up with a solution for that, or we re-architect and just break tons and tons of apps. We don't really like breaking apps. UAC kind of broke enough already by having you not be an admin, so we chose the other path. And there are ways to do it. There's a knowledge-based article on how to try to keep the two different sets of map drives in sync. In general, we recommend transitioning towards UNC paths where possible, but that's the underlying reason why. When I talk about elevation, when I go to elevate, I go through a shell execute operation, and shell execute determines whether or not I should elevate. That goes into the app info service. So I have to have that service running, which goes and checks with a binary called consent.exe. And then if you say yes, whether through policy or not, then it will go through and launch the process as an elevated process, and then reparent, so it looks like that was launched by the launching process. Let's walk through that architecture and the impact of that as well, so you can understand if you hit any of those consequences. One that I very rarely see when talking with customers about applications, but I have seen, is that even though we reparent you to make it look like where you launch the process is the parent, it's not your actual parent. And one of the things you get from your parent, in addition to your token, is your environment block. So if you are passing information by setting environment variables and then launching the app, it doesn't get those environment variables because the service doesn't have those environment variables set, and they don't get passed down. So one possibility for failure. The other interesting thing is, what is consent.exe checking? Finally, he's launching a group policy editor at MMS. How far are we into it? We're like 15 minutes into this already. But all of this does revolve around policy. When you call into consent.exe, right, elevation is not just always show me a dialog box. Elevation is more complicated than, oh, how do I, go ahead and make dialog boxes go away, or say yes, no, what's the thing there? There's a whole pile of settings which exists under security settings, local policies, and security options. You can also kind of shortcut your way to the security settings by going into secpol.msc. The user account control options will tell you how we answer that question to consent.exe, and they differ based upon whether you're an admin or a standard user. If you are an administrator, you've got a few choices. Your choices go from make you type your username and password again, which no human wants to do. It's an option, right? But no people actually want to do that. Dial it back and say, just make you say yes or no, right? And hopefully by reducing the number of prompts by auto-approving Windows binaries, that's that setting, we begin to reduce fatigue that drives reflexive yeses, all the way down to elevating without prompting. Elevating without prompting leaves UAC on. You will never again see a dialog box from now until the day that you die or change this policy. It also means that anything that asks to run as an administrator gets to run as an administrator. Boom. I'd like to be an admin. OK, here you go. Sort of like being Thor walking down the street with your hammer, and every single person who walks up and asks to borrow your hammer and get your godlike powers, you say, OK, and hand it to them. For those who are going to turn UAC off as the alternative, this at least gets you the infrastructure for all of the rest of the goodness in the procedure. I don't recommend it in the enterprise, though. But that's what consent.exe is checking. Here's the other interesting aspect of this elevation loop. When I talk about how do I get into this shell execute and prompting for elevation, I didn't make that clear what causes things to elevate. So let me do that now. Let me give that time to load. There are 3 reasons, and only 3 reasons, why you will ever see a UAC prompt. Reason number 1, the developer asked for it. Developers on Windows have the ability, by modifying a bit of XML that gets shipped with the program, to say, I need administrator rights to work correctly. So it could be prompting because the developer said, I'd like it to prompt. Option number 2, it could be prompting because the IT administrator chose to have it prompt by applying the run as admin flag to it. Option number 3 is the real confusing one, and I'll demystify it to you by showing him, which is it's prompting because we think you're a setup. Bit of historical context here. When we first enabled UAC by default, that was on the beta 2 builds of Windows Vista, we track every single day a number of applications, commercial applications, on the existing latest production OS and the one we're building. And the Vista timeframe was at about 1100 the day we made this change. The day before we turned it on, the last beta 1 build, we were at about a 93 to 94% success rate of legacy XP applications still working on what at the time we called Longhorn. The next day, we turned on UAC by default, and our success rate went from 93% to 20%. 4 out of 5 pieces of software that used to work on XP no longer worked. We thought that that might not be very satisfying. So what do we do about that? And one of the big problems we saw was, oh, none of these are installing, because we have all these setup.exes that are running as standard users and not getting to program files. How do we get all of those existing setup.exes to actually appear and get elevated? Well, we detect them, and we've got heuristics. And the heuristics turn out to be something that you can go in and see using the Compatibility Administrator tool, which we shipped as part of the AppCompat toolkit. Side note, the AppCompat toolkit is now hiding inside of the Assessment and Deployment Kit, or ADK. You can search for it. For a while, you were able to find the old one, which was really weird. It didn't redirect you. It's in the ADK. And you can look for setup, and here's the logic. It's not too complicated. We look at various parts of the binary. If the internal name includes the word setup, the original file name includes the word setup, or, if you happen to be in Japan, setuappu. If the name of the app includes the word setup, then we think it's a setup. And there are 4 strings that we look for that. Setup, update, right? Here's the word update. Patch, right? And we try to exclude a few things like add patch, dispatch, dispatcher, and actually go to the top here, select one. And installer detection looks for INSTAL. That's how we determine you're a setup, and that can lead you to an elevation prompt. That's it. The developer asks for it, the admin asks for it, or we think you're a setup. That triggers a UAC prompt, and nothing else will. There's no logic that checks to see whether it's necessary. It's all this heuristics before we launch you. Right? So that's elevation and how we get there and how you control it. When it comes to administering it, what I think matters most is ensuring that you really line up your policies to meet the scenario for when you're having someone assist a standard user. There are really two different ways. I can either have a policy that says I'm going to have someone assist them remotely and have them be able to elevate from the help desk over a session using whatever screen share technology we're using. If it's Microsoft Remote Assistance, terrific, because that's got all kinds of built-in support for UAC. But if it is not, if you're using Link, I've seen Easy Assist, I've seen most every other like Altiris remote clients, I've seen all kinds of other remote clients. If it's not MSRA.exe, almost none of them, none that I've ever seen, and probably nearly none, will actually remote the secure desktop where we put the prompt. So we need to line them up for either one. So if I were going to say for my standard users, I want the help desk to be able to provide credentials over a remote session. Well, step one, let them provide credentials. Step two, I need to go in and configure and turn off the secure desktop if my tools don't support that. Step three, you find this one. This one confuses everyone. We haven't talked about UI access yet, right? But there is a UI access component that determines whether or not you'll be able to actually send keystrokes to that elevated window. That has to be configured on the app itself. There's no policy for that. Those three things lined up, the help desk can provide credentials. The other alternative is, I don't want them to see something asking for a password, in which case there are fewer moving parts. You just say, you know what, just say, nope, can't do it, auto-deny. And no moving parts. And now I've got it configured to meet the scenario. Right? It's one of those things like so many in group policy where if I go one by one and try to pick what sounds like the best option, I can end up implementing no complete scenarios. It's real important to think this one through and consider the help desk scenario for how that works. So, we've done tokens, we've done elevation, the process of getting to elevation. We still haven't gotten far deep enough to understand all of the other potential impact is for why you really might want this. So let's start talking now about integrity levels. So in addition to my identity, we saw a difference in my token, right? We saw I'm me with these groups, these privileges, and I have differences there. What's also interesting is I now am able to make authorization decisions based upon how much I trust a process. So I'm going to use the PSExec tool. It's one of the tools from sysinternals. My good friend Aaron Margosas presented a session yesterday called Sysinternals Primer. If you haven't seen that, I recommend that's a great watch. He always does a really fun session. I'm going to use PSExec to launch something in low integrity, and I'm going to launch Notepad. And then I'm going to view the integrity levels. So to use that, I'm going to take a tool called Process Explorer, another sysinternals tool. And what I've done with Process Explorer is I've added the column for integrity. And I'm actually going to elevate Process Explorer so I can see details from all of the processes. And I'm going to use the window finder to zero in on Notepad. And you can see that I have launched Notepad with low integrity. So let's back up. What's integrity? Integrity is an expression of trust. Technically speaking, the integrity level is a 32-bit number. which means there are 4 billion possible permutations of what it could be. We found use for about 4, leaving us 4 billion minus 4 options to expand to in the future. We're using actually a couple in different places. But if you conceptualize it as being low, medium, high, and system as being the 4 that probably are going to come your way most of the time, you'll understand enough of it. And they're really just sequential. Low is less trusted than medium, is less trusted than high, is less trusted than system. System is where your services are going to be running most of the time. High typically represents an elevated process. Medium, standard user. And low is untrusted. That's when you're trying to sandbox something. So I've launched Notepad in this sandbox, this low sandbox. What does that mean in terms of what I'm allowed to do? So let's go ahead and write a test. And we'll try to save that. And I'll go ahead and put that in my documents. Right, I'll just call it test. And try to save it. And then, hit an error. I love this error. You don't have permission to write to my documents. Would you like to save it in my documents instead? This is why you never trust error messages. Because when they're writing them, they're trying to predict why you might happen and be helpful. If you go in and muck around too much, they stop being helpful. But what we've gotten is access denied. If I launch Process Monitor, it's almost like a whole other sysinternals talking here, isn't it? If I launch Process Monitor and try to save it again, right, then I'll go ahead and stop it. All right, come on, catch up and start processing window messages. Oh, he started again. Let's go into Tools, and we'll do Count Occurrences, and I want to look at the result code. I have 115 access denieds. And I want to just include from Notepad. I want to pull out any registry calls. And, oh, yes, here's what I'm trying to do. Access denied, trying to write here. Now, my user account has plenty of permission to write there. But the default ACL for any object that you don't explicitly add an integrity label for is medium no write-up. So I've got a folder medium no write-up, I've got a process at low, and we just compare them. As we're doing an access check, hey, if you're low and you require medium and you're trying to write and it's no write-up, access denied. Boom, instantaneous. We don't even bother checking if you as an identity are allowed to go there. That's integrity. Now we specifically call it integrity because of how we configured it. Integrity implies that you can't modify the system, which is very different from privacy, which implies that you can't read the system. The default is no write-up. It's not no read-up. And the reason why it's not no read-up isn't because we didn't think privacy was a good idea, but because the failure rate was so catastrophic that it was impractical for us to do that. But the platform supports it. Let's go ahead and open up my documents and delete some my leftover stuff here to kind of clean up the window. Let's make a new text file. And this is in, we'll call it integrity.txt. Oops. I won't save those. I'm going to open this integrity.txt that I just created. And now right here, I'm going to have a problem with saving it. Whoops. Let's do a file save. Still going to have a problem. I'm still hitting those access denieds because of the medium. But that's configurable. So I'm going to use a command line tool called CHML. CHML is a tool that Mark Manassi wrote and posted on his website that allows you to change the integrity level. You can also do it via code. You can use cackles.exe to modify the level itself, but not the policy. right? So I'm going to use CHML because I'm interested in modifying the policy also. So I'm going to do CHML for, let me go into the document, CD, documents, CHML, and I'm going to go into integrity. Oops, not desktop. Documents. No, integrity.txt. And I'm going to make this a low integrity file. And after making it low integrity, now I no longer get access denied. Now it's permission allowed. Same me, same credentials, but now by setting the integrity level of what I can write to, I'm able to make it there. So I've given explicit permission. That's how we make the browser work. So if we think about where we see low integrity processes today, we see it in web browsers. We do it in Internet Explorer. It's there in Chrome. Adobe Reader 10 and above implements low integrity. Office 2010 and later implement low integrity in their protected view. In order to support functioning, there are some things you need to save. I'm a web browser. I probably have a cache, which means I have to mark that folder as allowing a low integrity process to write there, but not let it write to anywhere else. So that's the baseline. That's integrity levels. So I've got low, medium, high system, and I can change it. What's potentially interesting is I don't just have read up and write up and execute up as a set with no execute. I can actually go in and change the policies. So if I CHML integrity.txt and integrity medium, I can get that blocked. I can do no read up as well. So let's go ahead and try to open this again. Same one I just had opened, but now I've set the no read up policy. The default is no write up. I said you can't write here. I modified it to be no read up. So now I can no longer read it either. Now I've implemented privacy. Personally, I do this in one and only one file. I do it on my Quicken file because I really don't think that my web browser needs to go mucking around inside of my Quicken file. There's kind of nothing else I have that I'm interested in protecting, but that's potentially an option. I can change these policies. Very few people are implementing that because very few people understand it. I've got a level, and I've got the rules of what you can do at that level, and they're separately modifiable. All right, so far so good. How are we doing? You guys can interrupt me with questions anytime you want to, right? I'm not paying you to come here. You paid me to talk, so yeah. Not print. We don't enforce printing in any way. So when we talk about the integrity at the access check level, that's literally you're calling the create file API to say open this file, and you give it a set of things of what you want to be allowed to do, like read or write or execute, right? And you can modify it at that point. So that's where it's intercepting. It's literally impacting the access check API and not the higher order operations. So it's not like IRM. So IRM would be a higher order construct that has to have participation from the applications that are doing the reading and writing and printing. This is very low order at the Windows API level. Yeah? So on, I've never experimented with it, so I don't want to misstate it. I would experiment and see what behaves and doesn't. It's all the same access check permissions, but I'm not sure what interception would happen along the way. Certainly on Windows, on that system, it would have the same rules, but what gets passed across, I would want to experimentally validate before I made a statement that could potentially be wrong. One more question. Are they considered a security boundary? No, there are very few things that we consider a security boundary. We have virtual machines are a security boundary. We don't take too many because a security boundary means if anyone finds a way to get around it ever for any reason, all of a sudden lots of people find themselves in a conference room for a long time until it's fixed. We're real cautious about what we do there. This is designed as part of a defense in depth strategy. And you'll see as we kind of complete the Windows 8 app story that we really are layering and layering and layering. So this is foundational. It applies. Usually confuses the heck out of people the first time they hear about it, which is why I'm trying to kind of go through and do some explaining. So that's integrity levels. That's reading, that's writing, files, registry keys, really any kernel mode object. On top of that, we then had a more interesting problem to conquer, which is, OK, so I've protected you from going in and modifying the files. But now, if you think about it, I have processes running at varying levels of trust. I maybe have a web browser running at low. I've got standard user apps. Maybe I've elevated something. If I'm in the sandbox, interesting aspect of how Windows works. Windows works by sending messages. And you can see how that works using SPY++. Right, so let me pull up a calculator. Here's a calculator. Let's go ahead and find this window. SPY++, incidentally, I'm guessing very few people in today's world have any reason to know that this even exists. This is really helpful for those who write really old school, what we in the dev community call Petzold style C code, where you really care about the individual messages. Most humans use UI frameworks that are way above this level, and so it's an occasional troubleshooting tool. Here I'm just using it as a demo tool. It's part of Visual Studio, and that's where I'm gotten it. But what it does is it tracks all of the messages. All of the UI frameworks in the world, from Visual Basic to .NET to Java to the new Windows APIs, all abstract this away so it looks like there's all of these properties. But the reality is, the way Windows communicates with it is by sending messages. If you want to understand what's in an edit control, what the user has typed in someplace, you do not just go and ask for a property of that control. Instead, you send it a message. What text is in your control? And it sends one back to you. Here's what's in my control. When you move the mouse, it sends a message. When you click a button, it sends a message. Hey, I pushed the button down. I lifted the button up. I pushed it down. I lifted it up. When I do a keystroke, it sends messages. 100% message-driven architecture since Windows 1. Hasn't changed a bit. And these messages do not have security descriptors. So now if you think, I'm the bad guy, I'm sitting here inside of this sandbox in a world where I'm pretty sure there's, at least on Windows 7, a button right here. On Windows 8, it kind of hides. Right? You got to go all the way in the corner. By the way, you do still have a start button, just in the corner. We just don't take up the pixels all the time. And other apps that are sitting on there, if you're locked in a sandbox, but you can send a message and not have a security descriptor to check, what happens? You just have someone else who you're pretty ssure is there. You go to explorer.exe, you start sending it some messages to have it do some work on your behalf. Send it the Windows R keystroke. Get a run dialog. Type something in there by sending messages to that dialog. All of those dialogues are well-known windows. And if you don't know the specific names, you can ask the window manager for the names. And they'll bring you right to it. Boom! You walked right around it. So we block that as well through a feature set called the User Interface Privilege Isolation, or UIPI. Quick demo of how that works. So I have here an application that's designed to create new users. And they've gone through and they've done an elevation, and now they have an out-of-process elevated COM component. You don't actually need to know that, but for anyone who wants to sort of know what's going on, that's how this is done. But this window right here is a window owned by this medium integrity process. And the bad guy is another medium integrity process. The operation is a high integrity operation. So without any protection on the windows, look at what the bad guy can do. Boom. He just UI automated his way to getting himself added to some group. What user interface privilege isolation does is it has this window, right? In a case where this window is owned by a high integrity process, window messages are blocked. And it's really straightforward. There is a whitelist for every process of the messages that you will allow through. So we let a few through by default. Other than those few, we don't let them through at all. So now I just swatted it down. Direct comparison. Medium to high. Are you on the whitelist? No, I'm not sending it. The window manager never delivers the message. That way you can automate something more trusted than you to get it to work on your behalf. What impact does that potentially have on you? Well, here's one bit of feedback that I've gotten from several administrators. So I'll go ahead and explain it. One of the things you could do in the past, bing, drag and drop from Explorer into your command line window. How many of you have done that? And how many of you noticed that if you do that into an elevated command prompt window, that doesn't work so good? That is because drag and drop works using window messages. They don't get delivered. Now, you could whitelist them if you wanted to, or you can just type it, right, and use tab completion to kind of get around some of that. But all of these revolve back down to the same fundamental concepts. All right? That's why I'm spending 75 minutes talking about the fundamental concepts so you can intuit your way into, oh, that's why that crazy thing happens. So far, so good? UIPI. Now, it's interesting, and how I try to explain to people, why is it you're still talking about all this crazy stuff that you did back in 2006, today in 2013? How come? Well, because it is legitimately hard. And by hard, let's give an example of someone who didn't understand that concept. I just showed you a way to get elevation of privilege by using UI automation to a medium integrity process. Let's see if we can find some developer who may have done something wrong there. So here we have a dialog box that changes the system time. And as you remember, that's an admin operation, right? I wonder what integrity the process is that hosts the UI. Oh. So who doesn't yet fully understand the impact of UAC and Windows security that's been around since 2006? A developer who works on the Windows team doesn't have that. So it's okay if you run across some of your folks who don't either. But this is what's going on. So that's foundational, and we start looking at how we can spot what's medium, what's low, right? We see that we've got low integrity. Let me get the tree view going on here. iExplore.exe. We have a medium integrity process hosting a low integrity process. The tab is actually owned by this low integrity process, and it lives in a sandbox. This architecture is shared by Chrome. Where did you hide on me, Chrome? There you are. And it uses a scantily documented level called untrusted, which is even below low. Right? We see it in Office 2010. We see it in Adobe Reader 10 and above. I'm using 11. And I can go in and see the exact same pattern, which is a medium integrity hosting a low integrity. What's that medium guy doing? He's a broker. If I think about the web browser, I probably want to be able to save files someplace. I see a picture on a search. I probably want to actually have it on my hard drive, not trapped and unable to write it there. How do I do that? The low integrity process has to ask the medium integrity process to do it on its behalf and then hand it the data. And that medium integrity process handles enforcing the rules for what it's going to allow it to do. So in the case of IE, the rules typically are you have to present the user with some UI. There is no option to automatically save this off someplace without the user getting involved. But if you're choosing to save a picture, you make them choose the location, and the medium integrity broker process will do it for you. So all of this infrastructure is fundamental. I need to close that before my stage starts to smell too bad up here. That was a joke, by the way. You can giggle. Okay, it wasn't that funny, so you don't need to giggle. And it is because of the dependency on that infrastructure that UAC is actually required for Windows 8 apps. Right? So what it was required for on Windows 7 was protected mode in IE. If you turn off UAC, there is no protected mode because it relies on integrity control and it relies on UIPI and all of these other UAC features. Turn off the feature, and the security feature, depending on that fundamental feature, goes away. Just makes sense. But most people don't mind too much. I mean, personally, I get a little nervous, particularly if I'm an admin, right? If I'm an admin and I'm running a web browser and there's no sandboxing there, that means the web browser is an admin, which means the internet is an admin on my box. And it turns out I don't really trust the whole internet to administer my computer. So I lose that, but not the end of the world. If I turn off UAC on Windows 8, I don't get all of my newfangled Windows 8 apps. And there are a lot of really good ones. Oh, really? Screen resolution is too low. We're going to fix that. See how the screen likes that? All right. There are a lot of really great Windows 8 apps out there. This is my personal favorite. That's all it does. How many of you are still on XP, by the way? Anyone? Handful? Yeah, that's what most of the work I'm doing is helping people break up with it. That's our new terminology. It was retire. Now it's like it's time to break up. Things aren't working out so well anymore. I wrote this app, yes. Got live tile support, too. So you can actually see all the time how many days you've got left. Is it in the store? I have to implement the snapped view in order to do it, and this clunky old computer doesn't have high enough resolution to support snap view, and the only time I ever have time to write it is when I'm on an airplane. Right? Like, I don't know if any of you have heard of Stock Viewer from any of my app compat sessions, right? The Stock Viewer app was written on a grand total of 4 plane flights, big ones. That's where I actually have free time, and since this one doesn't support it, I've got no way in which to test it and see if it works well. So I've got a new machine coming. It actually arrived Monday, so I'll actually be able to support that. And once I meet that quality bar, I can put it in the store. So if anyone wants to be able to count down for your friends and family, we'll make sure that that's possible. Right? But that is the reason why we actually make it harder to turn off UAC on Windows 8. Right? Interesting fact, what do people most associate with UAC? The prompts. So if you just do a search for the word prompt, guess what comes up? Oh, change your UAC settings, huh? If you bring this all the way down on Windows 7, UAC is off. If you bring it all the way down in Windows 8, UAC is still on and on auto approve. So there is a big difference because we consider it to be fairly impactful to not have any Windows 8 app on Windows 8. You can still turn it off by going in and disabling it for everybody, right? So some of our policies, right, and my personal opinion, I hope there's no one from the group policy team here, but I think I've reverse engineered how group policies are named at Microsoft, right? They take some guys and they walk up to a keyboard and they just bang their face on it. And any actual English words that come out, they take and put in the product. So you would think this thing that talks all about administrators would be something applying only to administrators. No, that's the on-off switch for everything. Rather conveniently labeled. My other favorite labeling is... hey, someone's mentioning me. Phil, nice to meet you. I love this policy. Allow UI access applications to prompt for elevation without using the secure desktop. Remember how I talked about lighting up your group policies and saying you have to turn off the secure desktop? And your gut reaction upon seeing this would be like, ooh, I don't think I want to do that. Let's just do it for the UI access application since it already has to be UI access. Problem solved, right? Well, here's what's slightly inaccurate about this. By UI access applications, they don't mean all UI access applications. They mean specifically msra.exe using an undocumented internal API that no one else can ever use. That kind of gets hidden in the meaning there. That's our baseline. On top of that, there's all kinds of new constructs that get introduced to help to make a more secure application experience. Now, make no mistake about it, I know that I'm at MMS and just opened Visual Studio. I may be the first person who has done that and actually brought up C++ code on the screen. We are not going to learn how to code today. I just want the demo app, and I need to configure the project a couple of times. So I'm going to go ahead and build and deploy this new application. I'm just building an application, readying it for side loading. Right? So it's an internal application. This is apparently being recompiled in its entirety, which is really convenient during the middle of my demo. And I'm going to test it out. And all the application is going to do is try to save a few files. That's its only purpose for being. Wow, you're really compiling everything. That's fantastic. And it's going to create a file. So once we get it opened up, oh, yesterday was Patch Tuesday, so all of my symbols are invalid. That's fantastic. It's not TweetDeck, actually. It's the Twitter application just running in the background. But hey, you know what? I've got nothing to hide. So feel free, if you want to be on the screen, if you've got some kind of thing where you want to do that, add AppCompat guy, you're going to be on the screen and you'll be on the video. Right? It'll be like one of those at the baseball game where you stand up and make funny faces. So I'm going to try and save a file. Real simple. But because I'm in a sandbox, I'm going to get access denied. I'm trying to write it to my documents library. That low integrity sandbox blocks it from happening. Okay? So we'll go ahead and we'll stop it from running. And the reason why it blocks it from running is because it's just trying to create it directly, and we have not given it permission. So we have this notion of capabilities that we added. Capabilities get represented to the security system as additional SIDs sitting in the token. So if I wanted to allow something to write to the documents library, the developer would say, I'd like to write to the documents library. That'll go through and require a rebuild. That's going to probably go and try to find symbols again. Let's cancel that. Always refresh your symbols after going through and doing a Patch Tuesday. I was yesterday, too. Super annoying. Where are you? There you are. I added the capability. If I go into Process Explorer, I can go and I can find it. Right? So the process itself actually lives hosted under this particular service. So it's kind of buried and hidden in this sort of strange, awkward location. But if I go into the security settings here, I actually find that, hey, here's my documents library capability. So I've added that. As a result, let's go ahead and clear all the filters. Reset, OK. Clear that out. And go back over to the SDK, write the file again. It's called sample.dat. I can do a filter to find it. So path contains sample.dat. Then include. And, oh, that's terrific. I find that here's sample.dat. Here's all the file work that's going on around it, and it's being written. But what's interesting, let's get the search out of there. Exclude that. And the antivirus engine, I don't need that either. Let's exclude that. And Explorer, I don't need that either. Let's exclude that. We're now really zeroing in on what's actually happening. My process never wrote it. This is another example of the broker doing it. I have a medium integrity broker process, in this case called runtimebroker.exe, provided by the Windows Runtime API framework, that it handles it for you. It enforces the capability. It says, hey, you've got a documents capability? Great, I'll go ahead and allow you to do that. Capabilities are how you tell the broker what you're going to allow it to do on your behalf. Broker is medium IL. So here's your sandbox. Here's your path out of the sandbox. And it's going to enforce rules governed by capabilities, which are represented as SIDs. Now, these rules are applied by the runtime broker. So the other thing I could potentially do is I could try to write the file directly using a create file API. You don't need to know the name of the API. This is an old Win32 API that just writes it directly. So if I go in and try to write that, I'm going to get the infamous error 5, access denied. And what I could do with that error 5 is go back into Explorer. Actually, let's get into the command line window. I don't want an admin one, but I want a standard user one. And I'm going to do, let's do CHML sample. Let's see, I need to make one first. Let's make one. Let's copy this and paste it. I'm going to rename it sample2.dat. Sample2.dat. And I'm going to set it to be low integrity. And as low integrity, I ought to be able to write to it just like I could in IE or when I brought Notepad down. That should work correctly, right? Of course not. Because there's a brand new dimension. So we've got capabilities, which are enforced by the broker. We also have this notion of being inside of an app container. So if I go back into the details of file access.exe, I have this entry here called app container in my SID. All Windows 8 immersive apps live inside of an app container. And that app container is another security construct where I have to have permission to do something as an app container. It's universally applied to all app containers. Now, I don't want to type this in front of a live audience. I'm pretty sure that wouldn't go well. But what I'm going to do next is icackles sample2.dat to grant. Paste to that identity, full control. And that's succeeded. After doing that, I've said low integrity, OK. This app container, OK. And I can open that file. Another layer on the onion of security. So it's not just everyone lives in the same thing. Because if you think about how this sandboxing technology starts to break down over time, it's just your web browser. Here's the cesspool where all the web browser stuff lives. OK. Then you add in Adobe Reader, and then you add in Office, then you add in another one. And on Windows 8, particularly on Windows RT, it's all of your apps, except Office, all living in app containers. And if they're all sharing the same cesspool, it's no longer protection. They're all in the cesspool. So we need to not only say, hey, stay out of the medium stuff, we need to say, stay out of each other, too. So if you have an app container entry in your SID, we then also enforce that you have to have permission as an app container to write someplace that you weren't supposed to go. Now, here's the other thing that I'm starting to see a lot in terms of permissions. I want to explore this one, which is we saw that we went through and we're using a capability to say it's OK to write to your documents library. And that gives you full permission to do whatever you want to there. You shouldn't need this. This is full permission to go into your documents library without consulting the user. If I remove this and rebuild and launch again, it will fail if I try to write it directly. However, Oh, come on, symbols. Blowing my groove. Mental note, always cache symbols before beginning. There we go. Writing directly will lead to an error. But if I involve the user in the conversation, I do not need the My Documents capability for the user to select a location in My Documents and have it be created. I only need the capability to allow the application full access without the user being notified. From a security-conscious perspective, how many people are going to save something and insist that they not be able to choose where it gets saved? Not a lot, right? But it's one of those, again, generalities. If you read the literal text of what's put in front of you, it seems like, oh, it's going to write to My Documents, therefore it needs that capability. Wrong. If it's going to write to My Documents, you just need to let the user pick to put it in his documents. And then the broker will say, oh, that's okay, they went through a file picker, good to go. Continuing to strengthen defense in depth and come up with different solutions to do that. And this extends in one other dimension as well. This is what I want every button to actually say, by the way. Sweet. I thought that was funny, but I'm easily amused, so. Is creating objects. This is another aspect of the security onion where things can break out of this world and start interfering with other things. I created an event, and on Windows 7 or on Windows 8 with the desktop app, if I create an event and I give it a name, right? So an event, any kind of synchronization object, some kind of file object, some kind of sharing, anything, I give it a name, it lives in that session namespace. If I'm the first person to get there, I can do one of two things, because the next person that says create event, if the event already exists, will just get the one you just made. And as a result, you can do name squatting. Get there first, create something with an event that you know some other app needs, and break that app. That actually happens. Or snoop on it. Right? To create a file mapping object, you can snoop on a file that it's writing. You'd be like, OK, I'll go ahead and take the one you've already got there. That's perfect. And here you go. So for Windows 8 applications, we don't just give you an event sitting in the base namespace. We actually inject into the name of the event the SID of this app container to make it unique and contained to within the confines of that app container. Another layer on the onion. And all of that comes together to build this notion of let's have a secure platform that allows me to have some isolation. But to the earlier point, none of these things are security boundaries. It's just defense in depth. So the final bit of defense in depth really comes down to the human factor, which is we, for the App Store, are trying to put in quality criteria and inspection before we deploy. So not only does the platform help protect you, the mechanism by which it gets delivered to the platform is also there to protect you. Code will always have imperfections, and so will the humans, right? But we're at least applying both of our strengths, our ability to apply a code-based set of rules and our ability to have a set of policies which we can modify based upon anything we actually find. And the same is true if you are building applications for side loading. When you build them for side loading, you are digitally signing them and saying it's OK to run them. So you're providing that stamp, the equivalent of what we do when we load it up into the store. So the question then becomes, what rules are you going to enforce? And how are you going to explain that? Are you going to look and say, hey, your app has every capability there is, right? That's the equivalent to what developers used to do, and I'm sure you probably have found a few apps where, you know what, every time we call an API, we just call it for all access, because why not? I might need this someday. Right? Anyone who's ever done standard user work finds that that's one of the big plagues. Same thing here. Like, hey, I might need the capability that My Documents, I'm writing there eventually. Let's go ahead and get permission to do that. What are the rules that you're going to apply? Because that rule is a very important part of your total end-to-end defense in depth. So with that, wow, I think we got through all the fun stuff. That is the end-to-end security story for the infrastructure of apps. So let's kind of trace back through where we came from using our lovely PowerPoint presentation here. We talked about tokens. We talked about how we elevate. We talked about setup detection, all those rules. We then branched into integrity levels, built upon that with UAPI. That's your foundation. We've added new functionality in terms of capabilities and app containers, as well as the way in which we run applications and have the signature enforcement to behave that way to help you build a more trusted application experience, because in the end, that's what we want people to do, to feel like they can drop apps on here right and left and have them, thanks for the awesome song, you're welcome. I'm not even really sure where the first name ends on that one. I kind of all mashed together. And with that trusted application experience, you'll load more and have more fun. So with that, thank you very much for attending, and enjoy the rest of MMS.